Hello everyone, this is Jimmy, and welcome to episode 25 of Project Ozone 3. I love just watching this farm work now. You know how before I liked to watch our sifter? Well, this is the new proof that our base is functioning. Although you can't really leave it up for too long, because that like beating sound, it kind of sounds like a heartbeat, doesn't it? It gets kind of creepy after a while. In fact, I think if we add a couple more drums, we can really make it sound like a creepy heartbeat. Let's try that. There we go. I think that's a little better. Anyways, the functional effect of having more drums is that the plants tend to get harvested a little bit quicker. But nonetheless, here's the farm we built last episode, and ended up wiring up a lot of the crafters, and here are the assembled materials. Neat. So as we go, whenever I encounter the need for a new, raw material, instead of, the way I'll probably make it is just by getting the relevant seed. So if we go here and see, there's a quest line for So it's like if we end up needing a bunch of Blizz essence or what does this do? Blizz rods? Blizz whatevers? Yeah, Blizz rods. Instead of setting up a Blizz farm, I'll probably just somehow scrounge together some Blizz seeds. Anyways, so with this now being our main source of raw materials, I think it is finally time to tackle that capacitor factory we've been working towards for like the last, half dozen-ish episodes. So when you look at the recipe for capacitors, right, almost everything in here is actually just, a more or less a raw ingredient, with the exception of the capacitors, the Ender-IO capacitors. So we just have to set up a assembly line that makes, we need melodic capacitors for pneumatic craft capacitors, and microchips use transistors, which use energized capacitors. So we need to set up, but I think energized is on its way to melodic, is it not? It is. Sweet. So the other thing we want to do is we may as well, if we're making capacitors, we may as well make transistors while we're at it, right? It's basically the same thing, except it just uses energized capacitors. So let's get started on that. First thing though, because this involves a lot of, just simple crafting steps, like crafting table steps to make these, we need to set up our assembler block. And actually I have already done that somewhere over here. So this is just a molecular assembler block. Every other, what are the vertical things called? Rows. Every other row has a four, if you look in there, you can see the interfaces. And each interface is surrounded on 5 sides by a molecular assembler. So this design gets you 5 assemblers per interface, but at the cost of you cannot right-click the interface. It's literally impossible to go and check the status of an interface by right-clicking on it. Usually I do like to leave a face open for physical access to an interface, but in this pack, I think because we do a lot of crafting, like a lot of these recipes, it's a lot of crafting and not a lot of processing, because a lot of our resources, like our alloys, we can make from seeds directly, right? So we do a lot less processing than we do in other packs. Then if crafting is going to be the bottleneck, I want the fastest crafters possible, which means our molecular assemblers also all have full acceleration cards. So I said we can't physically right-click the interfaces there to check them, but we can still access them through the interface terminal. So when we're drawing up our recipes, say, what here has a crafting recipe? Microchips, right? We can encode this recipe, and then we can put it in the interface through the interface terminal. So again, the fact that we don't have physical access may be an issue if problems crop up. It makes debugging slightly more difficult, but I'm hoping that it'll be okay. Anyways, let's start by encoding the various recipes that we need. At least the various crafting recipes, and then we can come back to tackling the processing recipes, right? Because that's where the bulk of the work is. All right, I think this is it. There are 6 crafting recipes apparently that we need. The rest, stuff like making this has to go in a slice and splice, or making these has to go in powers. So now that we're at the processing step, I think there's 2 ways we can set this up. The first is to set up, a number of, set up a machine, put an interface on it, and put a recipe into the interface, right? Make it on-demand crafting. The other way is to make it like a background processing task, where we just have a machine that's dedicated to doing this job, and we're constantly shoving it full of resources. And that way, when it's crafting, it doesn't have to take up, say, a crafting CPU slot, and it doesn't require applied energistics to calculate the crafting tree. And the latter is more difficult to set up by a fair margin, because you have to set up everything as you don't get like the applied energistics gives you like the ability to define black box behavior, right? You can say, items come into this black box, and like these items come into this black box, and this item leaves the black box. And for any other part of your assembly line, they don't care how this black box works. Applied energistics just it abstracts it away. So if you choose to build it as an assembly line, though, you kind of lose a lot of this abstraction, but in return, you gain performance. And because of the scope that we'll need, the amount of things we have to do in this pack, I think the performance is relevant. So let's go with the latter, and we'll go with the more performant, but perhaps slightly more complicated setup. Anyways, for starters, well, I guess I need a few more recipes, but for starters, we have to make these basic capacitors. Good news is almost all of these resources just come directly from the farm, right? Like the red alloy ingot here, we need a smelting step, but otherwise it's just redstone and iron. So how about, smelting is a task that we need enough of that I'm going to dedicate some machines to it. So let's build a like a dedicated smelter type thing. I got a bit ahead of myself there. I forgot that we have to actually build the crafting CPUs before we can do auto crafting of any sort, processing or crafting. So for starting off, I like to just have a couple small CPUs. So I think I'm going to build two 64K crafting CPUs with 6 coprocessors each. There we go. I think now we can do auto crafting. Awesome. That is our first auto crafting task on this in this mod pack. All right, so now we have 4 Zenith furnaces that can service our smelting tasks. The way it works is that this interface, which will have recipes in it later, puts the items into the crate, which processes the items, which puts the results, or which puts the items into the crate, which splits it between the various furnaces. There's a power cell hidden in there. You can barely see that powers them, and the results go into the last interface, which I forgot to hook up to the ME network. But once that gets hooked up, then that'll just slurp the items back in. And voila, our first automation. So let's test it out. So those of you that are familiar with applied energistics might find this bit a little bit redundant, but bear with me here. The way you encode processing recipes is that first you have to set the pattern, the terminal to processing pattern mode, and when you can either directly import the recipe from JEI, so one red iron ingot makes, or one red iron compound makes one red iron ingot, but in case of things you make a lot of at a time, I like to actually replace, do the recipe myself and force it to do multiple stacks at a time. That way, if you need like 6, it'll make 180 whatever, right, 192, but the next time when you need 6 more, it doesn't have to make the other, it doesn't have to spin up the entire system. It can just use the leftovers from the previous craft. This way, it's just a little bit more efficient. It results in less total crafting tasks firing off, and yeah. So anyways, I'm expecting to see our interface here on the interface terminal, but I forgot something. I forgot to link the P2P network, so let's fix that. Oh dear, this is the last face on our controller that we haven't used yet. Not that we're out of channels on many of these lines, but like here we're using 5 channels, but I've already linked up that face of the controller. Technically, P2P channels are one-to-many, so that one face of the controller can serve, one input can serve multiple outputs. Let's see, where's my tunnel here? But then that makes it hard to tell like when you're about to actually run out of channels on a face. So I prefer not to do that. All that means is we just have to add another ME controller soon. Anyways, so now that we have our recipe, I expect, there we go, now it shows up as furnace. If you name your ME interfaces in a anvil before you place them down, the name that you have for them shows up here. Otherwise, the name here is the machine that it's connected to, but in this case, it's not actually connected directly to a furnace, right? It's connected to a storage crate, so the name will show up as medium storage crate. And that doesn't really help you identify what what the task is that interface is for. So now that we have red alloy ingots, in the system, I can say, if you already have an item, by the way, you can middle click it with your mouse to request more. If you don't have an item, then here, let me show you something I don't have. If you don't have an item, or if you set it to craftable mode, you can just left click it. But if you have items, then you can middle click it. And this is something we'll need 1 million of. So let's say, give me, I don't know, 5,000. How does that sound? Apparently not very good because... There we go, 5,000. So make me 5,000, 60,000 bytes, 39,000 redstone, go. And we can view that crafting task. Again, the bottleneck will be how quickly it can make these red iron compounds, I suspect. Yeah, the crafters are actually slower than our smelter, ironically enough. But we'll be seeing here, every now and then, 3 stacks of this show up. It gets split up between these, it barfs it into these. I do have the ore processing upgrade in here in case we do, process ores with it. But it also doubles some other things randomly, like a double stone or cobblestone to stone. I don't know. Anyways, and then the results go into here, and we can see that as that happens, our task gets marked complete. Awesome. Next, I want to modernize our mini factory here that's producing energetic silver and vivid alloy. Unfortunately, those two resources cannot be crafted with mystical agriculture. So that means that we still need to continue to use the alloy smelters for them. But we can improve this process because all the inputs that go into it, can be crafted with mystical agriculture, right? Like this is electrum, which I don't think we have a seed yet for. Yeah, we do not, but we can make one. Likewise, electrotine glowstone, we do have seeds for. Here, cobalt and ender pearls, we can replace, instead of inputting from a crate, we can just use an export bus to send them to here. So I think I'm going to need to make a few seeds before we can continue. We need electrum and cobalt seeds. So let me do that, and then we can modernize our alloy factory here. All right, I've added cobalt and electrum plants and the processing for the various essences. So that should provide us with, practically speaking, an infinite supply of it. So let's go back to that factory and see what changes we can make. So now instead of having to supply let's see, we can get rid of this alloy smelter altogether. Well, let's start from the beginning. We definitely don't need these furnaces anymore, so these can go away. All right, those are gone. We don't need this alloy smelter anymore, although I'm sure we'll end up reusing the block itself somewhere else. Let's see, this one we still need, but we can supply it with these resources directly, so we no longer need to keep a cache of them. Oh dear, that's a mess. So instead of supplying it from drawers, we'll just use an export bus. I'll hook up the wiring later, probably off camera because that's just running wires, but we need a capacity card because we're giving it 3 different items and as many acceleration cards as we can fit. So I want it in round robin mode, so that'll provide it with these resources. Let's see, next, this still needs to continue to put resources into the drawer and send it to this smelter, although we no longer need our cobalt source here, right? We can replace this with an export bus as well. And likewise, we don't have to provide ender pearls through a drawer anymore. Alright, I went ahead and wired it all up as well. Since my experience in OmniFactory with ME conduits disconnecting from any cables randomly, right, like this connection, I found would randomly disconnect itself. I've been trying to avoid ME conduits, but let's be honest, they're so convenient being able to run in the same block space as... Which way do I want? Being able to run in the same block space... There we go. Being able to run in the same block space as item conduits. if I was running, if all my energy were energy conduits as well, I'd probably just deal with the potential disconnection bug. But whatever. Enough of that. Now I'm going to throw a few upgrades in here because that'll hopefully cause our machines to turn on. And you can see now because these now have more slots, all our machines turn back on, and all our resources are still being automatically supplied. It seems one of them has a much faster capacitor than the other. I also made a handful of other high quality capacitors because I'm sure we'll be putting them to good use. So we can now replace this one with that one, and that'll run faster. Awesome. So this takes care of energetic silver and vivid alloy ingots. Next is, I think we need two more, right? Melodic alloy and crystalline alloy. Neither of these can be made with essences directly either. So I think melodic alloy is the easier of the two. We'll start there. Chorus fruit, I believe, has a crafting recipe. No, it does not. But okay, so normal chorus fruit has a essence recipe. So this is just End Steel also has an essence recipe, and Landium. I'll put the landlord back into our mob farm, I guess, so we can farm that. So that'll produce melodic alloy, and since we have room right here, I think I'll put that alloy smelter back and make it here. Now, when configuring this export bus, we need one more card. In addition to the capacity card, we now need a crafting card. And those of us that are those of you, I guess, that have watched my OmniFactory series, these are, you should try to use them sparingly, because in order for the ME system to export something that uses a crafting card, it has to calculate, the crafting tree, right? It has to say, first I make this, then that, and that's because for the chorus fruit, we need to craft it. We have some that were generated by our bonsai tree, but if we look at chorus, we only have 2,000, chorus fruits, which is not nearly enough. So anyways, this is now in the process of making melodic alloy. I guess I'll replace one of these trims with the drawer to hold it, and then I'll set up the mob farm to do our landium ingots. So right now our landlord spawner is a powered spawner, but that's easy enough to switch over to a woot spawner, right? We just have to tag one of these. I should have put my gun on my hotbar first. Wow, this is laggy. Anyways, and then we can convert this into a woot spawner. Now, I think I actually made these structures a couple episodes ago, but I haven't put them to use yet. These are just copies of the first farm we have, but I figured soon enough we'll need to be spawning more than one or two types of mobs at a time. So now this is spawning landlords, which drop landium ingots, and nothing else here is particularly interesting, just landium ingots. So I'm not sure if I hooked up the items yet. I have not. Okay, so I'm just going to hook this up to, the ender chest as usual, and then that'll complete this part of the project. All right, that wraps up melodic ingots. All of these components are now automated, and jeez, is this smelter fast. All right, so one left, and that is crystalline ingot, the hardest of the bunch. So the gold is trivial, that one's fine. Grains of pieciality, however, either through a sag mill or a manufacturer, we have to put pulsating crystals. And let's see, pulsating iron, easy. Electrochene alloy, easy. Empowered diamantine crystals, not so easy. So I think what we'll do is, let's see, one empowered, maybe we'll make the empowered diamantine crystal on demand. Because of it's a relatively complex recipe, it's much easier to do it on demand and and allow yourself to take advantage of crafting cards than it is to try to just set up a factory to make one specific item. And I think I'll empower the black form. So I guess step one, let's set up a empowerer to handle on-demand empowering requests. Alright, so this setup's pretty simple because it's only a single empower. I'm not doing any fancy parallelization because I simply don't think we need it at for the scope that we're going to operate at. So we have an interface named empower. It puts the items into here. pretty important that you set this interface on blocking mode, because otherwise if you have two recipes running at once, you can end up getting mixed inputs. So from the crate, we're just extracting, and first we try to insert the center item so it has a higher priority and it's filtered. It's a whitelist filter. So far it's only, diamantine crystal blocks. So when we order, and then onto the sides, the display stands, they insert the item just on a lower priority. When it's done, the item is first pulled out of the Empower by a hopper, and then it's withdrawn from the hopper by a item conduit. This is to handle a potential race condition where, so a race condition is where the order of things happening matters, and you can't deterministically say A will happen before B. So that's how you can, it's called a race because the order of the two things matter, right? They're racing to complete first. So there is a potential very minor race condition here where the first item that gets extracted from this crate is the diamantine crystal. So let's order one, except I'll turn this off for now. So if we order one block of this, it should put these items in here, right? If the first item that tries to be extracted is the diamantine crystal block, and the completed product has not been extracted from the Empower yet, what will happen is the diamantine block will get inserted here, right? Because this item is already gone. It's already been used up. So what we need to do is we need to ensure that the item is extracted from the Empower as soon as it's done, and the item hopper, as far as I can tell, is the fastest item extract that'll take it the ticket's done. Using this setup, in theory, it's possible for this problem to still occur. I have never observed it, so I don't know if there's like special handling in the Empower that prevents it. But yeah, so all that's left is let's turn this extract back on. We see the items go in, and we also see that it's not actually running because I forgot to hook up power to our display stands. So let's fix that real quick. And voila, it's done. We didn't see it finish because it, finished off camera while I was flying back up. But let's order just a handful just to make sure it works. Let's go with 20 for now. So some of the things I still don't have automated fully, like alumite and Road Oct. I give up. This thing. This name shouldn't be that hard to say. I got it. It's rhodochrosite. Right? Rhodochrosite. I'm the best. Anyways, I was so happy that I pronounced it right that I forgot to actually place the order. Alright, let's go. So now we see the stuff comes in here. As soon as the first job gets fully extracted, a new one gets put in here, right? And then, because there's only one set of items waiting at a time, we won't run the risk of, getting jobs mixed. We won't end up with two alumite ingots on here and have an invalid recipe. So, this will process our diamantine blocks. Now, it's somewhat annoying that in Kappa mode, the standard recipe to, turn a block into the 9 crystals is gone, but we'll just have to use a factorizer for that. So I'll just hook up a factorizer. We'll need two factorizers, right? One to make the block, and like one to go 9 diamonds to a diamond block, and one to go from the block back to the diamonds. The next machine we're going to need to set up is a sag mill or pulverizer of some sort to turn these pulsating crystals into grains of piezoality. So first, let's start with the recipe. Again, I like to work in stacks. Doesn't really matter much if you do 1 stack or 3 stacks. And what are our options for it? We can do manufacturing or sag mill, and I think it's sag mill is faster. So let's see if we have one around. We do not. All right, I'll make one. And by make one, I definitely mean teach the A system how to make one. So remember this used to be, it's a pretty deeply nested crafting recipe, right? It's a lot of clicks. But once you teach the A system how to make it, it's a single click. Sweet. And here it is set up. So for the grinding ball, for this one, I'm choosing to use redstone alloy. You see there, the only bonus it has is reduced power use, and that manifests actually as increased processing speed. So the actual power use is the same, but the energy required per task is divided by, or is 35%. So basically, it runs almost 3 times faster. Anyways, I choose to use this because for the task that I'm going to be using this alloy or this Sagmo for specifically, it isn't affected by main or bonus output anyways, right? Like the crafting of, what are those things called? The dusts, grains of pieziality, is unaffected by the grinding ball. So when we craft these, we should see that the pulsating crystals get dumped here, and I guess it's not affected by the grinding ball at all, so this is completely useless. Whatever. It was processing very quickly anyways. Now that we are making that, we can finally set up the alloy smelter to make the crystalline alloy, right? Because the grains of pieziality was the other ingredient. So export bus configured to send grains and gold, and our alloy smelter makes crystalline alloy. Cool. So we just have to stash this away into our drawer and add, let's see, where can I put item conduits? I guess I can, do I have any Fluix conduits on me? Alright, anyways, now that this is, or once I hook this up, what color can I use? Anything past purple? Wait, this should be insert. Anyways, talking while working is hard. Cyan. Maybe? Cyan extract. Anyways, alright, so now that that's actually done, we can do the last steps, and that is to make the capacitors themselves. So we can get up to, I think, we can get up to silver capacitors just by crafting. Any higher than that, though, we have to go and start making empowers. So this is 1 empower to get to energetic silver, 1 to get to energized, and 1 more to get to crystalline. And this is done in a slice and splice. So let's set up 3 empowers and we'll chain them together to make these products. Now in this case, because we can avoid using, or I want to avoid using, taking, after each step, taking the ingredients back into the applied energistic system. So we can set this up as an assembly line instead. Alright, this is maybe more than a little messy, but it's 3 empower setups stacked vertically, and it is making the 3 tiers of capacitors: silver, energized, and crystalline. So the way it works is I have a ME interface providing all the raw ingredients we need from the ME system. Unfortunately, it does need a crafting card because both the silver capacitors, the pulverized coal, and the prismarine crystals are being crafted on demand. Then the bottom layer crafts the first tier capacitor. So every single input has a filter, and it just says, capacitor, silver capacitor here, whatever alloy coal. And then when it's done, it extracts on the same channel, because every input is filtered, and it has round robin enabled. So it'll split it between the display stands on the next tier that need it, as well as a output or like a storage place here, I guess. And what I'll do is I'll hook a storage bus up to that controller, and that way we have access to a small number of each tier capacitor at all times. And in fact, I'm saying I'll keep 8 stacks of energetic silver, 4 stacks of energized, and 1 stack of crystalline capacitors. And that just works up the tiers here. So this level makes the next tier capacitors once the bottom level provides it with enough input, and then the top level here makes the crystalline capacitors. So all we have to do is let's see, taking the crystalline capacitors from here, we just need to feed it into a slice and splice, I believe, with melodic alloy and some end steel, and that'll make our final product, the melodic capacitor. Well, I guess not quite our final product, our almost final product, the melodic capacitor. Lastly, but not least, we have a slice and splice, as I mentioned. It's being fed by this interface, which gives it the axes, the shears, and the resources it needs. And once it gets the last capacitor, I'm just going to give it this one from my inventory. But normally it'll get automatically fed in when that crafts it. And then, it crafts it into the top tier capacitor, chucks it into... Actually, I'm throwing it back in the ME interface. I don't think I want to do that, do I? Yeah, instead of throwing it into the ME interface, let's actually put it into a drawer, or maybe a buffer inventory right here. I intentionally built this slice and splice right next to our air power, because the next step we have to do with this melodic capacitor is put it through a pressure chamber. All right, switch this up a little bit. So coming out of the slice and splice, when it's done making the crystalline capacitor, it feeds into this impulse hopper. What an impulse hopper does is, based on the set of ghost items you put in the middle, it'll only transfer items from the input to the output slots if it matches the entire pattern. So, if we're missing any of these, it won't transfer anything. And if we have it all, it'll transfer one set at a time until it can, no longer transport anymore. So right now I have it set to never active. Oh, right. And I also have this level emitter that's set to emit above 2,000 capacitors. On the opposite side, I have something very similar set up for transistors. So emit above 2,000 transistors, and this is the item map for the items that make a transistor. So let's set both of these to, let's see, I want these active low signal. So active without signal and active without signal. So what that'll do is, you see, it transferred items until it had no more melodic capacitors, because then it couldn't transport anymore. All those items come into this storage crate, which will put them into the pressure chamber here that I built. That'll, gradually dump all the items into the pressure chamber. And once it's done, I have a filter on this side saying only extract transistor, pneumatic craft transistors and capacitors from the pressure chamber. So why is it bouncing? I guess that's just the way it looks. So once all these items are successfully inserted into the pressure chamber, they'll be crafted into resistors and capacitors. And for the time being, let's disconnect this so we can see the output product. But when it's done, they'll get dumped into this ME interface, and the idea is that that'll eat them back into our ME system. So this should, passively craft capacitors and resistors, or capacitors and transistors, until we hit our predefined thresholds, which for now I'm setting at 2,000. So let's see if have we transported enough items to craft anything yet. Not yet. What's it stuck on? Insert valid items. Not enough pressure in the pressure chamber to move the items. So we need more pressure here. So I think what we're running into is the fact that we're just literally too far away from our pump. So you see, our pump here is at almost 4.5 bars at times, but because of the fact that we're running through all this pipe, that's and we're losing some air pressure along the way, we're stuck at 3.3 bars on this end, and that's just not enough to move a stack of items at a time. So let's I guess we can set up an intermediate pump, like a booster pump over here. Maybe I'll set it up on this side of the air pressure, or the pressure chamber, so that we can have air pressure coming both ways. So yeah, let's set up another pump over here. So instead of exactly duplicating the system that we have on the other side, this is getting hot. Now that we have access to advanced pneumatic craft components, we can actually make something that's a bit more both robust and powerful. So the flux compressor goes up to 20 psi, which means we can safely go above that magic, or 20 bar, which means we can safely go above that magic 5 bar threshold that previously was making components explode. So what we do is, by putting a advanced PCB, which takes one of our precious printed circuit boards to make, but we're almost done automating those. We can now set a arbitrary threshold that the gauge will emit redstone at. Right now I have it set at 19. So at 19 bar, it'll turn off the compressor. Remember, it explodes above 20, so there's a small buffer. But if I let 19 bar through the pipe here, the stuff downstream will still explode. So what I have is a regulator tube module, also with advanced PCB in it, set at 4.9 bar. What that means is that no matter how high the pressure is on the high side, low side pressure, it will never allow more than 4.9 bar through to low side. So this way we can have a segregation of high side generating pressure and low side functioning pressure. That means that like the volume upgrades we put in this flux compressor are way more efficient because they get to operate at a much higher pressure. Anyways, what that should have manifested in is the ability for this thing to craft. And oh boy, we have a lot of items in here. I think what's happening is, yeah, this is still like, oh yeah, I can keep crafting. Let's keep going. But anyways, what's happening is, items are being dumped into here, and the results are being crafted, and our transistors are good. That's good to see. I think ultimately this stopped because I don't have our plastics automated yet, and it ran out of plastic. So anyways, it's going to go through all of this and craft as much of the, shove all the items in there, and it'll end up crafting a handful of capacitors and a handful of resistors. So let's see, you know what, let's take out some of these resistor components so we can get it to focus on capacitors. 1 second. Alright, I cleared out some of the resistor materials that we don't need anymore, or transistor, sorry, materials that we don't need anymore, and now our capacitor materials are being fed into the pressure chamber, which should result pretty soon in capacitors coming out the other end. I'm so excited. Let's get rid of these for now, just so they're not taking up space. We're almost there. Well, I think I did it. I saw it for a moment. Our first 7 automated capacitors. So once we hook that up, that'll suck the capacitors into our ME system. Come on, don't make me a liar. Maybe I missed the connection somewhere else. No, this is connected. It's not sucking the items up. I just wasn't patient enough. All right. Well, anyways, with that out of the way, our capacitor automation is basically done. There's a couple tiny things left. Let's see. Our plastic is still, manual. I'm still coming here saying, hey, I need a stack of cyan plastic. Yada, yada, yada. But we can automate this rather easily. However, I think at this point we've gone a little over length on the episode. So why don't we put off the last few cleanup tasks, like the automation of plastics. And I think there's like a component in the empowered diamantine crystal. Let's see. There's a component in here that we don't have automated either. The rhodochrosite. Yeah, the rhodochrosite. I think we have a way of making it, but it involves like rock crusher and granite for a chance. Anyways, we'll finish up the final few details tomorrow. But for now, we have automated capacitors. It's still pretty slow. I'm a little disappointed in how slow it is, but I mean, slow beats nothing, right? So for now, I hope you enjoyed this episode, and I'm glad we were able to finally get this done. I hope to see you in the next one. Take care. Bye-bye.